Hi, this is Vijay Ganesh. My presentation is about sampling rate conversion by rational factor interpolation decimation, which is I bar D. In decimation and interpolation, sampling rate conversion is achieved by an integer factor. When sampling rate conversion requires by non-integer factor, we need to perform sampling rate conversion by rational factor I bar D. Okay, what is the procedure? First one is perform interpolation by a factor I. Filter the output of interpolator using a low pass filter with the bandwidth of pi by I. The output of anti-imaging filter is passed through another low pass filter to limit the bandwidth of the signal to pi by D. Finally, signal band limited to pi by D is decimated by factor D. So you can see the block diagram here. First we have an input x of n, which goes through an interpolator, which converts into V of L. Then it goes through an anti-imaging filter. Then it goes through an anti-aliasing filter. We get W of L. Then it goes through a decimator, and we get the output Y of M. The anti-imaging filter and anti-aliasing filter are operated at the same sampling rate and hence can be replaced by simple low pass filter with cutoff frequency. Omega of C is equal to minimum of pi by I comma pi by D. It is important to note that in order to preserve the spectral characteristics of x of n, the interpolation has to be performed first and decimation is to be performed next. Filter bank. In some applications like spectrum analysis, it is required to separate a signal into a set of subband signals. There are some applications where this kind of subband signals have to be combined and represented as a single composite signal. For those applications, digital filter banks are used. Okay, what are the types of filter banks? First, in general, digital filter bank can be represented as a set of digital bandpass filters that can have either a common input or summated output. There are three types of filter banks. The first one is analysis filter bank, the next one is synthesis filter bank, the last one is subband coding filter bank. Analysis filter bank, it consists of m number of subfilters. The individual subfilter h of z is known as analysis filter. Description: all the subfilters are equally spaced in frequency and each have the same bandwidth. The spectrum of the input signal will lie in the range 0 less than or equal to w less than or equal to pi. The filter bank splits the signal into number of subband each having bandwidth of pi bar m. The filter HO of Z is a low pass, H1 of Z to HM minus 2 of Z are band pass, and H of minus 1 of Z is a high pass. The synthesis filter bank is a dual of M channel analysis filter bank. Description: in this case, U of M of Z is fed to an upsampler. The upsampling process produces the signal UM of Z of M. These signal are applied to a filter UM of Z and finally added to get X of Z. The filter GO of Z to GM minus 1 of Z have same characteristics as the analysis filter HO of Z to HM minus 1 of Z. So the last one is subband coding filter bank. If we combine the analysis filter with synthesis filter bank, as a result we will obtain a M channel subband coding filter bank. So I hope you understood. Thank you.